Hello, my name is Amanda Lamb, and I did a chemistry education research project with Dr. Stephanie Eveland Parrott at Wittenberg University, which is a small liberal arts college located in Springfield, Ohio. Our project involved making revisions to our general chemistry laboratory curriculum, specifically in the second semester course. Our main goal was to finalize the creation of a forensic science capstone experiment, and we wanted to focus on forensics specifically for two reasons. One, forensics shows up in many places in the media: TV shows, movies, novels, popularized by various crime procedurals. And so we wanted to generate student interest in chemistry as a subject and the chemistry laboratory through this implementation of forensic science, because currently there is no forensic science component of our introductory chemistry curriculum, whether in the lecture or in the laboratory. The second reason was that Wittenberg has an agreement with Bowling Green State University where students may obtain a Bachelor of Arts degree in chemistry in 3 years and then move on to Bowling Green for 2 years to complete a Master's of Science in Forensic Science with a specialization in chemistry. One of the major tasks that I completed throughout the project was synthesizing various education literature papers and determining what was most relevant in creating a science capstone, as capstones are not specific to science courses or laboratory environments, but exist across the disciplines. One of the first things that an instructor must consider when creating a capstone is the amount of student preparation that is required. This involves various aspects such as what skills students must have gained proficiency in prior to starting the capstone, and what sort of planning documents the instructor may require to have students turn in. For example, instructors may have their students turn in a teamwork contract if they're doing a teamwork laboratory, so that students have thought about how they will equitably divide the work. Or they may require a lab plan of action where students must create a document that outlines the specific steps in experimentation that we'll do in the laboratory to complete their capstone project. Additionally, it's important to consider how the capstone will be assessed. In assessing the experiments that the students are doing, we decided to create rubrics for each experiment, and the rubrics focus on the skills that are required to complete the experiments, such as accurate measurement of volumes and masses, as well as creating accurate solution concentrations and doing high quality titrations. We also included a laboratory report in our curriculum, so we created a rubric to assess the students' skills in scientific writing. However, we did not require students to complete an oral presentation. This was because currently we have no time in lecture to include student presentations, but with further revision and a couple of semesters under our belts, we may be able to include a presentation aspect. Capstones in the lecture often require both a report and a presentation, but some only require a report or even neither of those. are required to create an effective capstone, but it is something to consider, as it is important for students to leave their science courses with the ability to communicate science effectively, both orally and in written format. We also thought it necessary to consider how to effectively integrate the content from the laboratory with the content from the lecture. This is partially because we exist in a liberal arts institution, and interconnectedness across disciplines and across environments is highly emphasized. However, it also simply makes for a smoother experience for students because then they're able to see how everything fits together information wise, and see that lab and lecture are not discrete. They actually are different ways of comprehending the chemical content. Finally, one of the major factors to consider is what skills that students are not being assessed on in the laboratory currently. This is so that if there are some laboratory skills that are being under-assessed, then the capstone could be a sort of band-aid, a solution to that problem, a more permanent solution, or a temporary solution in the case of a band-aid, to make sure that those skills are assessed in a more thorough manner than they are currently being assessed. Or perhaps a capstone may offer the opportunity for instructors to assess skills that they are unable to assess thoroughly or at all in traditional laboratory experiments. The capstones tend to be much more involved, requiring more time commitment and more complexity of work required for students to complete. So then instructors are able to do things like assess scientific writing, as in our case, the students in our introductory courses do not actually complete any scientific writing, not until they enter organic chemistry, which is typically taken in one's sophomore or junior year. As I just discussed, a major part of my research was synthesizing the literature, so this concept map provides a summary of the main points that I gained from the literature, as well as how I applied it to creating and implementing a capstone in our course. So the physical things that I did, or the practical applications of the research, included creating rubrics, as I alluded to earlier, for each of the laboratory skills, and then for the lab report, reviewing the literature, of course, and then creating new pre-lab activities, and finally reviewing the learning objectives that are currently being addressed in our post-laboratory assignments in order to determine what skills students must use to complete the post-laboratory assignments. This is just to ensure that the learning objectives from our intro courses are actually being assessed, and being assessed in a well-distributed manner to make sure that we aren't over-assessing certain concepts and under-assessing other concepts. And our main theme in our research was focusing on increasing student metacognition, which is the act of an ability to analyze one's own mechanisms of thinking. This has been researched and validated across disciplines for several decades, including in chemistry-specific education research. And so all of the things that I completed for our research project involved making sure that they helped to increase students' metacognitive abilities. Thank you for listening to my research description and presentation, and I hope that you enjoy and take a little bit of time to read through the concept map, and please do